Welcome to science class. Today we begin a unit on astronomy, which is the branch of science that deals with celestial objects, space, and the physical universe as a whole. Now that might seem like a radical departure from what we've been doing so far. I mean, we're just abandoning the oceans and the atmosphere and the ground for outer space. What does that have to do with Earth science? Well, quite a lot, it turns out. Astronomy in general is deserving of its own entire video series, because it is the study of the entire universe, for crying out loud. This astronomy unit will focus on aspects of astronomy that do directly affect Earth science. How did Earth form? Why do planets orbit in ellipses? What is gravity? Why are there moons? What is the structure of our solar system? What do other planets teach us about Earth? You get the idea. This will not be a series on the physics of black holes and alternative universes and is there life out there and how spaceships work. Sorry. For these first few videos, we will also be focusing on the broader historical context and cultural impacts of astronomy, because I am the producer, writer, director, editor, publisher, and host of this YouTube channel, and those are the kinds of things that I find interesting, so there. This video is about early astronomy, what astronomy meant to them, and how they viewed Earth's place in the universe. By today's standards, it's pretty hard to call what the ancients did real astronomy. They observed the universe, but they didn't really study it scientifically. Because remember, these weren't scientists. Nobody was. The ancients used the night sky as a tool. It served as their compass and their calendar. But they also assumed the night sky could tell them what to do. The planet Mars is in retrograde? Uh-oh, that means we better prepare for war. A solar eclipse? Prepare for war! A comet? Prepare for war! You were born on a day when there was a lunar eclipse? Well, that obviously means that you are destined to be the next emperor. This is what you call astrology, and it's not science. It is make-believe, and we will not be giving it any credit. Now, I'm not calling the ancients stupid, far from it, in fact. What they were able to accomplish with very little information about how things really worked is astounding. They were able to predict the motions of objects in the sky hundreds or thousands of years in advance, and studying the sky gave rise to the greatest scientific achievements before the industrial age. Before we could start saving lives by understanding biology and chemistry in the 19th and 20th centuries, astronomy was always the most important and culturally significant area of human study, even though it was the one farthest away from our grasp and true understanding. The night sky, as I said, was man's compass and calendar for almost all ancient societies, and it was still used this way until only a few decades ago. Ships during World War II still used the stars to navigate because satellites didn't exist. Even today, the way astronomy shaped Western civilization is ingrained into our culture. Easter occurs on the first Sunday following the first full moon on or after the vernal equinox. That's why it's always on a different day of the year. Christmas occurs just after the winter solstice, which is nowhere near the time of year given in the Gospels for the birth of Jesus. The seasons, summer, autumn, winter, spring, begin on either the solstice or the equinox. The three pyramids of Giza mirror the alignment of Orion's belt, Stonehenge is an astronomical calendar, and so much more. The majority of man's cultural and spiritual connection with the universe is with, well, the universe. We think the gods live up there. We think it rewards and punishes us. We planted crops and migrated according to its patterns. We built pyramids that aimed towards it. We wrote stories of people who visited us from up there. And it continues to make those who care to look at it astounded. Let's get started. We will not be rewinding all the way back to Stonehenge or the Old Kingdom in Egypt. We will start with ancient Greece, or the Hellenistic period. While other cultures built impressive features and surely used the night sky, the Greeks gave us a far more important contribution. They invented geometry and trigonometry. While the Greeks didn't get a lot of things about the structure of our solar system correct, like with the sun being in the center and all, and while they didn't know that the universe was so much larger than the observable stars in the sky, their contributions still paved the way for others to more accurately measure and solve those problems. Trigonometry and geometry allow you to understand the relative positions and sizes of objects and put everything in its correct place. But of course, the ancient Greeks weren't scientists. They were astrologers and mathematicians. Astrology is the belief that information can be revealed about human activity and earthly processes by observing the movements and positions of celestial objects. When comets appeared in the night sky, man's most important calendar and one of his most important tools, people took that as a sign of something, usually a sign of something bad. People just could not accept the idea that maybe the reason things happen is because things happen. Everything to them had to happen for a reason, which is called teleology. They believed humans and Earth had to be special. Of course, Earth is the center of the universe. We live on Earth, and we're intelligent, which means we are important, so we have to be the center of the universe. They clung to this notion despite the fact that huge numbers of observations debunk it. Astronomy, as I hope to reveal to you over the next several videos, is a very humbling field of study. If you take it seriously, it totally dismantles the "we are the center of the universe" way of thinking, both metaphorically and literally. We are a very tiny part in a perhaps infinite expanse of time and space. Does this mean that life is any less precious? Well, of course not. To understand and witness the universe before you is beautiful and awe-inspiring. Sorry, that got a little bit poetic, so back to business. While the Greeks didn't have the right idea about how the solar system is structured, they did understand that Earth was a sphere, and it had been known for ages that stars shift their position night by night throughout the year. Those simple observations lead to some brilliant inventions. The astrolabe is an inclinometer. You have to calibrate it to the particular time of year, but if you aim what's called the alidade at a particular star, you can then find your latitude on the spherical Earth. This is GPS without satellites, and it's impressive. Then there's the Antikythera mechanism, which is technically an analog computer, and its gearing and radial dials could predict up to 19 years in the future certain celestial events like lunar or solar eclipses, moon positions and phases, and more. We are going to cover the contributions of individual early astronomers in the rest of this video, beginning with Aristotle. Aristotle has been by far the most influential logical thinker in history, which did not serve us well because he was wrong about almost everything. Unlike all of the other early, not really astronomers, Aristotle was not a mathematician. Aristotle was a philosopher who used intuition and logic to argue what the truth must be, which doesn't often work. But with regards to astronomy, Aristotle was sort of right about some things. He asserted that Earth was a sphere, but he didn't offer any experimental proof that it was. He also asserted that stars are spheres, but for the wrong reason. He also thought that the stars were not made of fire, which is true, but again, he argued it for the wrong reason. The reasons why he was wrong are important. Remember, the ancient Greeks, and I would bet most people in the world today, argued that everything happens for a reason, everything has a purpose, and the reason things happen is to reach some sort of goal. Aristotle thought stars had to be perfect spheres because it was thought that they were perfect and eternal objects. A sphere is a perfect shape. It has perfect symmetry in all dimensions. So stars must be perfect spheres too. He also thought the other planets were perfect spheres, but they didn't actually know what planets were. We're going to talk about that in a little bit. Aristotle believed the moon was a perfect sphere. He also thought that all objects in the universe must move in perfect circles as they orbit Earth. These ideas were considered astronomical gospel for 2,000 years. And when it was demonstrated that Aristotle was wrong, people didn't take it very well. The problem with geniuses is that when they are right, they change the world. But when they are wrong, everybody believes in the wrong answer to questions for a long time. Okay, so what about things that Aristotle got wrong? Well, there's the objects in space are perfect spheres and move in perfect circles thing, and Earth is the center of the universe thing, but there's a lot of others. Aristotle thought that shooting stars were ejected from clouds in the sky. Aristotle thought that the atmosphere extended upwards endlessly into the entire universe, which I don't blame him for. I would have probably felt the same way because they didn't know what air even was. He also believed that the reason stars shine is because of the friction they encounter by rapidly racing through the atmosphere, which was also his explanation for why the sun shines. That's actually extremely creative, and it is exactly why meteors burn up in the atmosphere. Because of light pollution, you've probably never seen the Milky Way galaxy at night, but the ancients could always see it. The Milky Way is our galaxy, and we can see it because it is composed of billions of stars. However, Aristotle insisted that the Milky Way does not glow because of starlight. Then there's... Okay, this one is so confusing, but bear with me. If you observe the position of one of the planets at the exact same time every night, say 10 p.m., you'll find that its position in the night sky, night by night, doesn't make sense, because it advances forward night after night, but then it briefly slows down, stops, reverses, then slows down, stops, and then continues advancing forward. This is called retrograde motion. How can an object moving through space do that? Well, it's an illusion. Its true cause is that Earth orbits past Mars at a greater velocity. Earth and Mars move in the same direction, counterclockwise, around the Sun, but when we pass Mars, Mars looks like it's moving backwards from our perspective. This completely destroys the geocentric model, because having Earth orbit the Sun perfectly explains why we see this observation. But the Greeks just could not allow themselves to accept that they were not the center of the universe. So here's how Aristotle explained retrograde motion. Aristotle believed in degrees of freedom. Humans can do more things than animals, and animals can do more things than plants, and plants can do more things than rocks. Which is kind of true in a way. Aristotle applied this logic to the planets. One quick thing. Without a telescope, you can't tell what the planets are. They look just like stars, only brighter, and they move. And before Galileo, everyone thought planets were stars. Aristotle said that planets were stars that have more degrees of freedom, and this is why they sometimes appear to move backwards, because they can. Do you see how absurd all of this is? This is why we need science. Those ideas are bananas. The problem was, those ideas were assumed to be true for centuries, and you could be killed for saying that they aren't. There were people from Aristotle's time that did not agree with him. Aristarchus of Samos, who was born 12 years after Aristotle died, argued for heliocentrism. He also argued that the other stars were objects just like the sun, which they are, but nobody else believed. They thought the sun had to be unique, because it's ours. It provides us with energy, and we are special. Sadly, all of Aristarchus's work has been lost. We only know about him because he and his theory is referenced by Archimedes in his book titled The Sand Reckoner. That book, this is amazing, was an attempt at calculating how many grains of sand would fit into the entire universe. Next up we have Eratosthenes. He is best remembered for coming up with a way to calculate the circumference of Earth, and for being not that far off. It was known that on the summer solstice in Cyan, modern-day Aswan, the sun was directly overhead. You could see the bottom of a well because the sunlight went directly into the well. This would also mean that a vertical rod would have no shadow. To the north in Alexandria, on the same day of the year, Eratosthenes measured the angle of a shadow cast by a rod known as a gnomon. This produced an angle of about 7 degrees. 7 degrees is approximately 1/50th of a circle. So if you take the distance from Cyan to Alexandria, multiply it by around 50, that should give you Earth's circumference. The standard length in that time was the stadia, and because there was no universal agreed upon distance for what a stadia is, we're not sure what Eratosthenes' real number was, but his range of error was probably between 10 and 15%, which isn't bad at all. Then there was Hipparchus, perhaps the greatest ancient astronomer and somebody whose name you had never heard until now. Hipparchus may have actually invented trigonometry. He's the first person we know of to have used a trigonometric table. I have no idea how he did this, but Hipparchus was able to calculate the length of a lunar month to within 1 second. He also calculated the solar year to within 6 minutes. To understand why that is so impressive, you need to forget the idea that a year is 365.25 days. Because it's not. It's 365.2421891 days. If a year was exactly 365 and a quarter days, then calculating the number of minutes would be simple. Just take 60 times 24 times 365.25. But the fact that it's not exactly 365.25 days makes it very hard to get precise measurements. Hipparchus's measure of the solar year was only 0.00114% off. You've probably never heard of a lunar month, but it's how long it takes the moon to orbit the Earth. And it's 29 days, 12 hours, 44 minutes, and 2.8 seconds. Hipparchus got within 1 second. That's an error of only 0.0000783%. To be so precise about those kinds of measurements that long ago is an amazing achievement. Hipparchus also cataloged 1,080 stars, and he thought the Earth was the center of the universe. And here's why that is infuriating. Hipparchus worked on a heliocentric model, and he arrived at the correct answer, which caused him to reject it. Now, what do I mean? If you work out mathematically how Earth moves around the sun, you discover that Earth orbits in an ellipse, not a perfect circle. Everything orbits in ellipses. Once Hipparchus realized that's what the mathematics was telling him, he concluded that the math must be incorrect. Objects in the universe simply cannot travel in ellipses. They have to orbit in perfect circles. It took over 1,700 years to fix that error. For 1,700 years, we were wrong. Nothing in the universe is more objective than math. 2 + 2 = 4, whether you like it or not. And planets orbit in ellipses, whether you like it or not. But they would not accept it. The last person we will discuss today is Ptolemy, who lived a few centuries later during what's called the Common Era. Ptolemy's crowning achievement was a series of books titled the Almagest. This was a masterpiece of astronomical observations. It predicted lunar eclipses and star positions, which are possible to calculate because the moon orbits Earth and the stars reappear in the sky predictably. Ptolemy also listed 48 constellations, which he kind of stole from Hipparchus. Remember, the sky was a tool, a compass, and a calendar. This book was the most thorough encyclopedia and user manual of that tool that had ever been made. This lifted Ptolemy to an almost mythical status, which unfortunately also meant that the Almagest became a dogmatic text, which was too bad because Earth was the center of the universe, according to Ptolemy. Now, why so many errors? Several reasons. There's no apparent motion of our planet. It's imperceptible. The ancients not only thought the Earth was the center of everything, but also that Earth didn't even rotate. Now, I have no way to really prove this, but it's my strong opinion that the moon actually held us back more than perhaps anything. Here's why I think that. The moon does not appear to rotate. It does rotate, but it rotates once for every time it goes around Earth. The image we have of the moon never changes, and because we only see it during part of the day, it was reasonable to assume back then that the moon goes around Earth every 24 hours and doesn't spin. So if the moon doesn't rotate, why should anything rotate? Remember, everything else is too far away, and they didn't have the technology to observe other celestial bodies to see if they rotate. And the moon does orbit the Earth. To them, it looked like the moon orbited every 24 hours rather than about every 30 days, but it orbits the Earth nonetheless. So they were supposed to accept that, yes, the moon orbits Earth, but everything else orbits the sun. That's a hard sell to make. And of course, they knew nothing about other moons on other worlds. You can't see them directly. Then lastly, all of the predictions made by the ancients were amazingly accurate. It would have been impossible to convince them that they were able to make these calculations and predictions using their model, and also convince them that their model is still wrong. They were limited by the technology and strange quirks of their time, not just by faulty logic. Next time, we will fast forward to the 1500s and begin exploring the birth of modern astronomy, where we will begin to correct some of the errors that stuck around for so long. Thanks for watching.